What is up, guys? My name is Christian, and today I'm going to be explaining the mechanism of going from an amine to an imine. I know this can be a little confusing, so I'm going to try and make it simple, use some slang, and help you guys out. So, what are we trying to make? An imine. So an imine is a double bonded molecule to a carbon which has an R and R, and the top is R. Basically, you just have to know that it's double bonded to an N. That is an imine. So, let's demonstrate this mechanism and how we're going to go about this. So this is all we have to work with. Please be aware that the nitrogen always works as a very strong nucleophile. So as a first initiative step, what we should do is attack this carbonyl and then move one of these pi bonds, creating an anion on the oxygen. O minus. And because we have attacked this, we have now attached our molecule. But be aware that we do have to add a positive charge on this because we have given up the electrons and nitrogen is not happy with that. And whenever you have a positive on a nitrogen, you must take care of that immediately. So what can we do here? Let me give you a hint by making it look a little more, I guess, pretty. If you're thinking what I'm thinking is we're going to use the same nucleophile, which is very strong, to deprotonate one of these hydrogens. So this is going to come in here, it's going to take one of these hydrogens, and it's going to push the electrons into the nitrogen, making a very happy neutral nitrogen. HO minus NHCH3. Cool. So now, how do we deal with the anion that is on our oxygen? Well, if we look at the byproduct which we just created, we have made this as our byproduct. Remember, positive. So, using the anion, we can come over here and deprotonate our byproduct, taking a hydrogen, pushing these electrons and satisfying that positive carbocation on that nitrogen. Okay. Can you guys see this? OH, NH dot dot CH3. Okay, so what do we do here? Please do remember that the OH we can convert into water to make it a leaving group. So we're simply going to use another one of these, another equivalence of this. Remember that once you make a byproduct, you can ultimately use that byproduct as much as you want. So let's go over here, push this over here, and our new product is this. OH2 plus, because it gave up its electrons, H and CH3H. Now, we have a really good leaving group. How can we get this to leave? Think about it. What can we do? Well, if you're thinking what I'm thinking, is we use the lone pair on the nitrogen to create a double bond, and this is going to force water to leave. So water leaves the equation, and we now have our new product. Boom. H and CH3 double bonded positive because it gave up its electrons. Cool. So we're almost at our final step. What can we do? You're right. We go back and we use our original thing we used to deprotonate over there. So let's just introduce another one of these. And this is going to come over here, take one of these hydrogens, push the electrons to satisfy that positive nitrogen, and we get our final product. Sorry, that looks bad. So we get our final product. There we go. That is our final product. We have now formed an imine. So I think the main key points to take away from this is to remember that this is a really good base/nucleophile, and that once you protonate it by deprotonating a hydrogen in this part of the reaction, then you can ultimately use that to feed hydrogens to the oxygen with an anion. Anyways, thank you guys for watching, and I hope this helped.